Welcome everyone to the Unlocking Microsoft Azure AI Essentials and Generative AI Solutions. My name is Raj Madressa. I'm going to be taking you through the content over the next 90 minutes. And maybe just to set the expectations, I won't talk for 90 minutes, but a brief introduction about myself if I can, and a little bit around the logistics. So from a timing perspective, as I said, it's about 90 minutes worth of content that we've got. That won't be just the PowerPoints. I'll do a couple of demonstrations as well. Somewhere at about the halfway point, 45 or 50 minutes in, we'll take a 5-minute stretch break. So if you can plan accordingly, if you need to deal with emails, any work-related things, etc., about a 5-minute break that we'll have halfway through the session. So just as a little bit of a way of introduction, if I can maybe just spend a couple of minutes, if that, introducing myself. And I'll do this through chat just to make things super efficient. If you can see the chat window in Zoom, that's my brief introduction. And it also gives me a bit of an excuse about something else I'm going to be talking about. So the name's Raj, as hopefully you've picked up. Surname Badressa, someone who doesn't dress well, if you want to pronounce it that way. I'm a software trainer, but working for bespoke training services. I worked with them for about 4+ years, been working with Microsoft technologies for about 25+ years. Background is predominantly in IT infrastructure, so delivering training courses for Microsoft and other vendors over the years, AWS, Cisco, Citrix, etc., etc. Expectations over the next 90 minutes to meet your expectations. I'm hoping your expectations, if I can set them, are really to get some fundamental understanding of Azure AI and generative AI in particular over the next 90 minutes. And also just to share something personal, I live in Auckland. I moved here from the UK about 20 odd years ago. Kept fairly busy with family life, got 2 dogs, and the reason I mentioned this is they may bark here in New Zealand. It's just after 1 p.m. So as we get close to after school time, that may cause a bit of chaos. I'll try and minimize that as much as possible. Maybe just to get a little bit of a feel for where you've all come from, what your expectations are. I don't know whether you've all seen the chat window in Zoom, but maybe just a quick introduction. If you could pop something into the chat window, maybe where you've connected from, your organization, if you're happy to share it, you don't have to, and maybe your role. So that way I've got a little bit of an idea of where you're all connecting from, whether it's in Australia, New Zealand, like myself, which company, if you wish to, what your role is within your organization. It'll just be interesting to get some feedback, some interaction. Feel free to pop that into the chat window. And also, of course, incidentally, if you have any questions as I'm going through, feel free to also use the chat window to prompt any questions that you may have for me as part of the content. So any takers, feel free, like I said, just to pop something into the chat window. You should be able to send it to me and everyone if you wish to, but it's not mandatory. But it can be one-way traffic if you prefer. I can be doing most of the talking. Perfect. Okay, thanks, Mark. Okay, so head of architecture at Chemist Warehouse. Okay, fantastic. Okay, Kelly from Brisbane, welcome. Okay, Etienne, if I've pronounced that correctly, Wellington. Okay, Cloud Ops, fantastic. So far, I guess we've got a couple of you Australia, one New Zealander. Okay, Adam from Melbourne. Okay, 17 years in an IT infrastructure manager role. Fantastic. Thanks for sharing that, Adam. What I'm hoping is you're either all relatively new or looking to get some greater understanding of this whole talk in the industry and in the general world, I guess, around artificial intelligence. Perfect. Thanks, Nitesh. Another Auckland dog owner, senior infrastructure project consultant from Fujitsu. Vish from Auckland. Lewis or Louis, if I pronounce it the other way around, from Sydney. Okay, fantastic. So now that I've got a bit of a feel where you're all coming from, thanks for the interaction. It helps. Feel free to also use that for asking questions. Let's get into the content. Let's start using this 90 minutes that we've got together, because I know some of you obviously investing time. Actually, before I start getting into the content, if you can't stay for the full 90 minutes, if I could ask a favor, take a snapshot of this QR code. It will give you the opportunity to put some feedback around what you've experienced today. You can either use the QR code if you can take a quick picture of that, or I'll post the link, which I should have actually had planned. Bear with me. I'll just pop the link into the chat window. But yes, if you can't stay for the full 90 minutes, welcome, Jeff. Thanks for connecting from Perth. If you can kind of complete that survey, I'll also have the same link, of course, at the end of the session. But yeah, if I can catch you just in case you're going to be missing the session, feel free to use that. There's a survey, you can pop your email address in, etc. And that gives feedback to Microsoft and Bespoke. But let's move further forward and talk about the content we're covering off in this session. So we're going to start with some fundamental AI concepts. Understanding, well, what exactly is artificial intelligence or AI? And the building blocks that really make up AI. We're going to talk machine learning or ML. We'll talk about some of the fundamentals of the services that Microsoft have in Azure to support artificial intelligence or AI. And then we'll kind of key in on a couple of aspects in particular, NLP or natural language processing concepts and capabilities in Azure. Before we finish up, and we've kind of saved the best for last, if you like, really the big discussions that some of you are hopefully already planning around is this idea of generative AI. So we'll have some discussions, some concept aspects, but we need to understand some of those other building blocks before we can get to the generative AI. So let's start from the beginning with some fundamental AI concepts. So artificial intelligence, in the same way that I guess your own human capabilities that you have around, looking at specific information, making decisions based on that information. Well, really what we're doing is we're allowing the software to do something very similar. So by looking at patterns based on historic data, maybe predicting outcomes, in the same way that maybe as a human, you kind of look at things and intuitively can pick up when things are not normal and maybe make some decisions. Likewise, of course, with artificial intelligence, it's looking for abnormalities and then making decisions accordingly. Without even thinking about, I guess, subconsciously, these aspects you're probably going to be doing, like dealing with visual input that you may have. So, of course, pictures, and of course, whatever you may be doing as you go through your normal day-to-day life. Also engaging language. Some of you may have one or more languages, of course, that you know, and then also extracting information as it suggests to gain knowledge. So really what we're talking about here with artificial intelligence is doing the same things that we naturally automatically do, but of course, incorporating that in computing systems and software that can provide the same kind of capabilities. Now, artificial intelligence is by no means new. What I think has happened over the last couple of years is, of course, there's been greater awareness of it, particularly with the discussions around generative AI. If I cast my mind back, and I am quite old, as you can probably tell from the hairstyle, when I was doing my university degree, part of those discussions as part of my final year project was around artificial intelligence and machine learning. And this is going back, I'm probably dating myself at this point, about 30 years. So it gives you a little bit of an idea that AI is by no means a new concept. Now, what we may use AI for, again, depends. I know some of you mentioned, of course, the organizations that you're from, but is this because we're using machine learning? Now, machine learning is the foundation, as this slide suggests. And by the way, these slides that I'm using, you'll have a recorded version of these slides. I won't be providing you the slides at the end of the day, but I'll provide, or Fiona, my colleague, will provide you a link so you can download the recorded version of this. You'll probably hear me saying the same things on the recorded session when you review it, but also I'll provide some links at the end of the session so you can get the same content. But anyway, coming back to this point, machine learning, predictive models based on data and statistics. It's the foundation for artificial intelligence. So with machine learning, I guess thinking the same way that you might learn a new skill. So if you're learning to play a musical instrument, learning a new language, taking on a new sport, something like that, of course, you've got a bit of a process where you have to learn the rules, the specifics of how that particular language works, or how to play that musical instrument, how to cook or bake something, whatever the criteria might be. And that is really the same kind of thing that the machines will go through in the same way that you have to learn. There's a bit of a process, and we'll talk about the specifics involved in that very, very shortly. So that's machine learning, and that's going to be one of our focal points of the session today. Now, the next part of the equation is computer vision. So interpreting the world like we do visually. So of course, unless you have sight impairments or something like that, of course, maybe having to deal with, hey, what about all of these images that I'm dealing with, interpreting accordingly. So computer vision, or CV, is another component of, or another common way that we may implement artificial intelligence. Then also, as I mentioned, natural language processing, or NLP, dealing with spoken language, responding appropriately. Document intelligence, data found in forms and documents as it suggests, extracting information from that. So this is referred to as knowledge mining. That could be unstructured data. And then finally, of course, the idea of generative AI, which, as we can see in the definition there, creating original content in a variety of formats, whether it's language, whether it's images, whether it's code, so on and so forth. So for this session, just to give you some highlights in terms of what we're going to be focusing our attention on, we'll be spending a little bit of time with machine learning, natural language processing, and generative AI. We won't do too much with computer vision, or CV, or document intelligence, or knowledge mining in this limited time, of course, that we're going to be spending together today. Now, before we get into the specifics, I think at the outset, it's worthwhile considering some of the principles that we need to think about with responsible use of artificial intelligence. So thinking about things like bias. That gives you an example there, but of course, if the model that is being used to approve, as it suggests, loans, and models is a specific term that we'll talk about with machine learning coming up shortly, but really what we want to make sure, of course, we don't have a situation where there's going to be bias, and that could be bias based on gender, that could be based on race, whatever the criteria might be. So we must make sure that the decisions being made by the artificial intelligence solution is fair. We also need to make sure that there is reliability and safety. I guess there's been a lot of talks, again, over the last couple of years about autonomous vehicles and some of the impact that they may have if there's a system failure. So again, making sure that that is top of mind with any designs that we incorporate of AI. Also dealing with private sensitive data. Some of you may be working with organizations or for organizations where you have personally identifiable information. And if that information is being used for the training process, we've got to make sure that's stored in a secure fashion. Also, we need to have inclusiveness, so considering, as I was mentioning, I guess, when I was talking about computer vision, maybe there's going to be situations where people are visually impaired, so have we also incorporated and included them as part of our design? Transparency. If an artificial intelligence system is making some kind of recommendations, we need to understand, well, what's the reasons why it's made that? If we're trusting this level of complexity, or these complex systems, I should say, to make some of these decisions on our behalf, we need to have some visibility of how it's made its decisions. So transparency needs to be incorporated. And then lastly, we've also got to think about accountability. If there is a problem that's driven by AI, who's going to be ultimately accountable for the decisions it's made? And just as a bit of a sideshow before I move away from responsible AI, just a couple of references. Some of this you may have seen in the recent press. So I'm going to share a couple of links as part of this discussion. So bear with me a second. For those of you in Australia, and of course I know we've got a mixed audience, some of you potentially in Australia, also in New Zealand as well. Just a couple of good references from the CSIRO about good AI, bad AI, and then decoding responsible artificial intelligence. Really just talk about some of the ethical principles like we're talking about. Of course, there's references directly from Microsoft that I'll share at the end of the session. But if you want to find more out from what recommendations have been provided by CSIRO, then do have a look at that reference there. And over and above that, also another link that I would like to share about responsible AI, a discussion paper set up by the Australian government from the Department of Industry, Science and Resources. So again, you may find this useful, this consultation paper, so have some references that you may want to have as part of those early discussions for your organization or those customers that you may be dealing with. So I'll just pop these directly in chat, take them away and use them as need be. And I guess there's been a couple of recent discussion points. You may be familiar with, of course, ChatGPT. I hope a lot of you are. So talking about ChatGPT and how Scarlett Johansson was a little bit miffed, I guess to say the least, around the voice that ChatGPT voice was using because it sounded eerily similar to something that she had in a movie that she was in. So yes, there's a few kind of ethical and discussion points that we may have to think about there. I'll post this in case you missed this story. And another one that caught my eye the other day. If some of you are working maybe for customers or organizations which are retail and making decisions purely and exclusively based on AI and the impact it may have. So this is a BBC article in the UK and about someone who was basically recognized as being a shoplifter from facial recognition technology. And she was, of course, escorted out of the shop and told that she could never come back in. And obviously it was a decision that was incorrect. So again, these are the kinds of things that we probably don't want to have the negative press associated with these things happening for our customers, our organization as part of that. So again, thinking very early about the responsibilities that you have when adopting and enabling artificial intelligence. So that said, I'll kind of leave the responsible aspects for you to go further into. I'll provide some resources at the end of the session as need be. But let's get more in, I guess, to the technology itself and understanding the concepts. So again, by the way, of course, if you do have any questions, feel free to just kind of pop that in chat. I'm keeping an eye on the chat window as I'm posting there. But let's talk fundamentals of machine learning. It's important for us to understand machine learning because as we're going to see when we start looking at things like generative AI, its foundations come from ML. So what happens with machine learning is it looks for patterns in data. We feed some data in based on some kind of past observations. Now, again, to be technically incorporating what's in this slide, it has some features and some labels. So let's take some examples. Maybe the features could identify criteria around whether a particular credit card transaction was fraud or not. And the label might say, yes, this was a fraudulent transaction, or no, this was not a fraudulent transaction. So we've got all that information, and it can look at the relationships between all of that data and then build some kind of mathematical function. It'd be very hard for us to manually kind of do this ourselves, but generalize that relationship between those features that cause that label, that value of this was a fraudulent transaction or not. And I'm using fraud as an example because it's a classic way that we would talk about machine learning, but it could be equally, hey, let's look at other criteria. And maybe for an organization where they want to predict how many ice creams are being sold, it's coming up in a later slide. So they may be looking at the seasonality, they may be looking at the temperature. So those would be the features. And then the label might be how many ice creams were sold on that particular day. Regardless, once the algorithm has looked at the relationship between all of those various features, it can encapsulate that into what's called a model. And a model can then predict, or again, machine learning specific terminology, it can inference what the value will be based on feeding in some new some features that it hasn't seen during the training process. So let's feed it in some new features, X1, X2, X3, whatever they might be, and let's make a prediction. Okay, yes, this is a fraudulent transaction from a credit card perspective, or no, it's not. So that's really some of the kind of high-level aspects of understanding machine learning. Repeating the process, machine learning model is trained, and that then generalizes the relationship between the various features to then be able to predict the label, because it can look at the criteria with some known values. And then, of course, it can have some unknown values that we feed into it that it can use then for predictions or inferencing. Now, this slide is quite complex to start off with. So there's a lot, it's a very, very busy slide. So I'm going to kind of focus our attention as we go through with this machine learning slide, that machine learning can be broken down in this example that we're going to focus on into two styles of machine learning, supervised or unsupervised. With supervised, we have some known labels. Like I said in the example that I've shown, credit card transactions rather, that we've labeled as being fraud or not fraud. So at that point, once we've got the data that's labeled, we can feed that in. The algorithm can then build a model based on the terminology we were using before. And then we can say, well, how would we like this machine learning model to predict? Its inferencing could either be classifications. I'm going to focus our attention on this side. Classification, something is or is not a particular class. It's fraud or it's not fraud. Or someone is at risk or not at risk of diabetes, if you want to have more of a health reference there. So that's classification, binary classification. It's either a 0 or a 1, it's a yes or it's a no. But classification could also be broken down further into multi-class classification. Hey, let's predict based on some measurements. You can see why we've got some pictures of penguins. Okay, let's predict some measurements that we've got about these penguins, which type of species it is, for example. Hey, it's going to be a king penguin or a gentoo or whatever the penguin species it may identify as. The important thing, I guess, there is we've got multiple classes, not just yes or no, or 1 or 0. We've got more than 2 classes with this multi-class classification. So again, depends on the kind of problem that you're dealing with and what you want to predict for the new label based on the features. So that's classification. So supervised machine learning, we've got labeled data, we feed that in, it can then classify and then predict whether something is or is not, that's binary classification, or from more than 2 classes, which is multi-class classification. So that's that side of the equation covered off, having gone machine learning, supervised, and classification. What about this other one, regression? Also with supervised machine learning, what we can get it to do is predict some kind of value. So examples they have, how many ice creams are going to be sold based on the features, in this case, the day. So maybe there's going to be more ice cream sold on a Saturday or a Sunday compared to a Monday through Friday, for example, but also the other factors or the other features that would come into play, the season, the weather, etc. Another common use case for regression examples that are given would be predicting the house sale price. So looking at all the criteria, the features would be the number of bedrooms, the location it's in, the amount of the plot size, if you like, for the property. Those would be our features, and then predicting, well, how much will this likely sell for? And that's a regression problem because we're not predicting a class like we are with the classification. We're predicting a value, a numeric value, whether it's ice creams or it's the sale price of a property. Really depends on the problem that you're dealing with. So that's giving us supervised machine learning options. With unsupervised, on the other hand, if we go back to the beginning of this kind of flowchart, if you like, unsupervised, we have unlabeled data. So we don't have any labels that we're feeding in. And what happens is the machine learning algorithm, it kind of groups things together. So maybe as this example suggests, hey, let's separate these plants into common characteristics. And of course, then it can have this cluster that it's building based on plants that have common characteristics. And then, of course, when it's done all that labeling, when it's done all that clustering, I should say, being able to predict which cluster something should be in. So there's a little bit of a story around machine learning. And really kind of building that same picture back to the slide a couple of slides ago. How does it do all of this? Well, it takes that training data. So again, if this is going to be our scenario where we're talking about using labeled data, so that's supervised learning, technically. We've got all of this past observations, which actually has the label to say what the value was for it. So whether that is, yes, this was a fraudulent transaction, or this is someone who then went on to develop diabetes, or whether, again, this is the number of ice creams that were sold on this particular day. So it uses that, builds the algorithm, trains the model, and of course, at this point, that's really the same place that we got to in the previous slide. What we now need to do is see how well this model's working. Well, we've got some data that the algorithm didn't see during the training process. This is referred to as validation data. It can use that validation data, feed in these values, these features, and then let the algorithm predict or infer what we think the value will be and compare that with the known value. So at this point, we can evaluate how good it is, comparing the predicted labels that the algorithm has used to the actual labels. Well, how many ice creams actually sold on that particular day? Or it's predicted it's a fraudulent transaction, but it wasn't. So we can then kind of work out through some metrics whether that meets our criteria in terms of performance. So we've got to have a way of evaluating the performance of the algorithm. So there's obviously a degree of complexity, and I'm going to show you some tools that you can use to help you with building that. But before I move on, a sub-feature of machine learning is something called deep learning. So again, sometimes you just refer to DL in the same way that machine learning is ML. And deep learning uses the same mechanism that our brains use. That is the idea of having these neurons that are all connected together into some kind of neural network. And the stimulation or the stimuli in response to something happening that happens in our brain, doing a similar thing with what's called an artificial neural network or an ANN. So again, the ANN is really just modeling the same way that our brain works and all of the different neurons that are connected there. So how could this be useful? Well, let's go back to what we were looking at in the earlier slides. Maybe again, we're looking to predict the penguins. So based on the input, we could have this deep learning, this deep network that's being built, this artificial neural network that's being built. And then again, based on the results as it's gone through these different neurons that make up this deep learning neural network, making the predictions, yes, okay, well, it's this particular penguin. It's predicted with a high degree of certainty, 0.7 or whatever it might be as part of the output. So again, deep learning, commonly used for specific types of machine learning scenarios, maybe looking at video and imaging data, for example. That might use a deep learning approach rather than just a kind of classic machine learning, which you might be using for numeric data, for example. Now, fortunately, you don't have to necessarily reinvent the wheel. And this is, I guess, where Microsoft come into play with Azure machine learning. So if you're looking to try this concept out without having to reinvent the wheel, as I say, taking advantage, of course, of Azure being a cloud-based platform that I'm sure a lot of your organization, a lot of your customers may already be using, and the fact we actually have this specific capability of using machine learning directly into the machine learning studio. And again, we can provide the data that we want to feed into it, and it can then provide machine learning capabilities and, of course, predictions that we can take advantage of. So what I thought I would do there is I'm going to break again a little bit from the slides. And again, within the time constraints that we've got, I'm not going to try and show you every single capability of the Azure Machine Learning Studio. However, if I could just break up the PowerPoint slides a little bit, here's a quick view of Azure Machine Learning Studio. So as we can see from here, without trying to explain every single aspect of it, we can maybe take advantage of some kind of automated machine learning, which can reduce the complexity of you having to go through that training process yourself without actually having to write any code. So you can see, as the kind of tagline suggests, let automated ML train and find the best model based on your data without you having to write a single line of code, or your organization having to write a single line of code. So just as a basic concept here, I'll show you if I pretend to create a new automated machine learning job, and I'll just leave most of the defaults as they are. I guess the main thing I really wanted to show you here is what's the task? What are we trying to do? Are we trying to do classification? So this could be that binary classification, yes, no, predicting that as the label, or of course, multi-class classification, whatever the labels might be that you're looking to predict, in this case, blue, red, green. Are we trying to do something that's regression-based, predicting a numeric value? And of course, other things that we haven't really got into, but NLP, natural language processing, and computer vision are also there as part of the process. What we can do is we can provide the data and let automated ML take care of it and build a model for us. Now, of course, there's a lot more flexibility and capability within the Azure Machine Learning Studio. I will show you, because this will become relevant for later on when we get into those aspects as well. There's a built-in model catalog that you can take advantage of. Now, again, you've probably been very familiar with the idea of ChatGPT. So these models can be something you can take advantage of without you having to go through the training process yourself. Now, there's a whole bunch of them. And like I said, we need to understand a little bit more around generative AI, and this will then hopefully have some context as we've understood that aspect later on. But I guess for now, for the purpose of this relatively simple demo, just showing you, of course, yes, rather than just showing the slide, the Machine Learning Studio, and how through various aspects it can help us with building, if we wish to, our own machine learning model by, of course, getting it to feed in the data and telling it how we'd like it to do its predictions. Would we like to have classification, binary or multi-class, or some kind of regression where it's predicting values? So that hopefully gives you a little bit of a starting point around ML. Again, feel free if there's any questions you have, just throw them into the chat window. I'll move that one off screen for now, and I'll move back to my slides. Now, this is really just a continuation of what I've just shown you. So fundamentals of Azure AI services. Well, starting point, if you weren't already familiar with Azure being a cloud platform from Microsoft, it gives us capabilities. So storing our data, which of course could be used in this case for providing machine learning capabilities. So it could be storing our data that's going to be used for the training process, providing the compute capabilities, again, for doing the training through various services. So this is really just a generic, hey, Azure can provide storage, compute, and services, and they live inside a subscription. The resources themselves are further collected together into what are called resource groups, and then we can have resources. And that's a pretty generic overview of what Azure gives you, if you weren't already familiar with what Azure is about. Now, specifically, as I've just shown you, we have Azure ML, which again can help you with the training, deployment, and management of ML models. We also have Azure AI services, so specifically covering things like computer vision or CV, speech, language, decision, and of course our focal point for later on in the session will be the generative AI component of that. Then there's also cognitive search, which can help with extraction, enrichment, indexing for searching, and knowledge mining. So again, there are services that may well mean that you don't have to reinvent the wheel. You can just take advantage of as needed. Again, depending on what you're looking to achieve. And once you build or use the Azure AI service to provide the capability from the AI perspective, and you maybe need to consume that for an application. So let's say, for example, go back to my financial one, a good example. Maybe we're working in the financial services industry, and we need to then provide as a credit card transaction is happening, whether the prediction is to say it's going to be fraudulent or not. We provide that to our applications that can then make decisions about what to do next through a REST endpoint that can be accessed in Azure. So again, just two parts of the equation. You've got your application, whatever that might be, and then there's the Azure AI service that, of course, can provide those predictions that your application may need. And again, I've used financial services, of course, clearly it could be something else. So that's something that you may design, incorporate, architect. Before I go into the next set of concepts around natural language processing, I might just, again, just to break up the slides a little bit, show you, of course, how these may fit together. Maybe these things may hang together. So if I go into the Azure portal, which, again, if you're not already familiar with, allows us to interact with Azure services accordingly. And what you can see here is there are various resources that I've already got planned and prepared for demonstration purposes. So I can, as I've done, show you the Azure machine learning aspect, so they can, of course, get access to the studio from there, but also Azure AI Studio, which I think I've already got open up elsewhere here. So let me just bring that over. Now, some of these things we've got to have some discussions around, because when we look at this Azure AI Studio, we haven't really talked about generative AI as yet, so you're going to see a little bit more around that. But some terms that might be good to see here. So the model catalog, the prompt catalog. So when we talk about prompt engineering, which is going to come up a little bit later on, I can give you some references to that. But I guess the AI services. So what am I looking to do? Am I dealing with speech data? Am I dealing with language data that maybe needs to be dealt with or translated? Is it vision, document, so on and so forth? So you've got a lot of capability within the Azure AI services, depending on what you're looking to do, without you, like I said, having to reinvent the wheel. Now, one thing I do want to point out at this early stage, because I think it's useful to show, if you're doing anything that's going to require access to the Azure OpenAI AI service, you'll need to make sure your subscription has been activated and enabled. Because they're, again, coming back to that responsible AI discussions, you must make sure that you've requested access to Azure OpenAI. Some of you, as organizations, you may have done this already, but as you can see here, if it is something you're looking to take advantage of, so they can effectively vet and make sure that how you're using the OpenAI models are going to meet the responsibility criteria they recommend. There's a reference there, of course, where you'll basically need to complete this information, submit the information, and then enable what's called the subscription, where you're running the Azure services for the Azure OpenAI services. So yes, just be mindful of that. I'll just post this link directly in, but you'll see that the way you get to it is when you start using the Azure OpenAI services, it will prompt you for that. So if you want to use the things like the chat service or the assistants, yeah, it'll say, yeah, you need to access Azure OpenAI service, and you need to enable the subscription accordingly. Okay, so there's a couple of concepts there. So let's move away from machine learning, specifically around natural language processing. Now, natural language processing, as the name implies, deals with language. And how it does so is it goes through a bit of a process of taking text data, raw text data as it suggests here, running it through some kind of pre-processing mechanism, turning it into tokens. Then, once it's tokenized the words, or it's completed the tokenization process, I should say, it goes through training. So this is, again, very similar to what we've just been seeing with machine learning, and it builds a language model. Now, you're going to see a little bit later on, we talk about generative AI, that we have large language models, LLMs, and what they're based around is a scale of text that's significant. So we're talking internet scale text, hence why it's referred to as an LLM or a large language model. But again, we'll come on to a little bit more around generative AI later on. But this language model, once it's been trained, can then be used for analyzing the text, maybe also looking from an opinion perspective as to whether this is sentiment analysis, which is positive sentiment or negative sentiment. Again, if you're doing something which is reviewing, maybe, or analyzing, I should say, reviews maybe of your organization, translation capabilities, summarizing all of the content, and then, of course, also using this idea of conversational AI as well. So you can use bots to interact with the data. Now, there's a lot of specific and probably deep dive technical detail around how NLP works. You probably don't need to understand all of these aspects necessarily, but it's going to come up in later slides. But if you are interested in it, of course, it's really good to understand, particularly if you're going to be doing your own training. But if you're just using the large language models, they're already ready to go, as we're going to see later on. But what can we do as far as NLP is concerned in Azure? Well, again, big long list of things, including language detection, sentiment analysis, as I mentioned, identifying whether someone's got any personally identifiable information, summarizing all of the content, question answering, etc., etc. So all of these things are capabilities that we can take advantage of in Azure AI, and that's just the language aspects. Then there's speech, text to, or speech to text, speech translation, etc., and then also a specific capability around translation. So really, again, taking advantage of some of the NLP, natural language processing capabilities in Azure AI is really going to make your life a little bit easier because you don't necessarily have to go through the training process yourself. So again, going into a little bit more detail around NLP in Azure, as this suggests within the language studio, so very similar to the machine learning studio I've already shown you, let's have a look at some of the things. Maybe we can feed it in some text, and it can say whether this is positive sentiment, negative sentiment, neutral sentiment inside the text. Maybe it can also do language detection or some kind of other classification based on your criteria. So just as a simple example here, maybe the text that's going to be analyzed is this statement here: I had a wonderful vacation in France, or holiday if you prefer. And of course, it can analyze the text and say, detect language. Okay, well, English is the predominant language that, of course, being used there. It's pretty positive. It's pretty certain that there's a positive sentiment that we're getting around that. I guess given the word wonderful there. So key phrases within there can also be identified through the text analysis. So wonderful vacation. Entities can be identified. So what we can then use is, of course, this analysis and then do something with it. So again, identifying positive sentiment, negative sentiment, whatever the criteria might be. It's also possible within Azure AI to build question answering capabilities. I'm sure you've all seen this capability in various websites. You may have this yourself on your own or some customers that you've been working with, but some kind of a chatbot. So using the chatbot to, of course, answer questions. And of course, we can put the common or the frequently asked questions inside a document, make that available within Azure AI. So of course, the bot can then respond accordingly. So Azure AI can provide the bot, can provide the responses, and take advantage of some of the information that you've provided as part of that process, that knowledge base. So as I said, you've got this Azure bot service, which you can then provide and incorporate and embed directly into your website, respond through other means as need be. And again, it will integrate with the AI language services and capabilities as well. And it's part of the conversational language understanding. So if you're building some kind of automation, so as this suggests, and I'm sure you've got some familiarity with various Home Assistants. I won't mention their names just in case any of you are like me working from home, and I say and trigger the magic word which switches on whatever your services that you're using. But yeah, of course, saying to whoever your assistant or whatever your assistant is to, of course, perform some kind of function. And what this conversational language understanding can do is, of course, understand the intent, in this case, to clearly switch the light on. And then, of course, the entity is being identified as the light. And, of course, it's been able to interpret all that information by understanding the utterance for what we've said. And I'm sure you've had many a situation, not unlike myself, where you've said something and it's been well misinterpreted, of course, by your automation assistant. So, of course, we've got to make sure that we're saying the right things. But yes, that's really, again, some capabilities we can take advantage of within Azure. We also have speech recognition and synthesis, so speech to text as need be. So if you're transcribing, maybe similar to what I'm doing here on this on the Zoom session, because I know the Zoom can do the same thing. Some kind of transcript service which is dealing with my speech, and of course then putting it into some kind of text that you can then review as need be, and vice versa, of course, text to speech as need be. So that hopefully gives us a starting point for understanding natural language processing. Again, I'll prompt to see if there's any questions, excuse the pun. I'll see if there's any questions, comments before we move into the next section. and I might give a brief overview, and then we'll have a short break because I think we've been going for about 40 minutes according to my clock. So I'll spend 5 minutes and then we'll take a short break. And then we'll come back and kind of show you some specifics around generative AI. And I think it's good to really position things. And this is why it was important for us to understand machine learning and deep learning before we get into what is the relatively new kind of kid on the block, if you like, with this idea of generative AI. So artificial intelligence, the overall term that, of course, we understood from the beginning of the session, really taking into software, allowing computers to take the same kind of approach that we have for human intelligence, and of course, kind of simulate that, if you like. So that's the artificial intelligence. Then, of course, a subset of artificial intelligence, machine learning. So allow machines to learn from the data and look at those patterns that we've talked about, and then make predictions based on unseen data, based on the training or trained model, I should say. And of course, we also defined the deep learning idea, where of course we've got these neural networks similar in the way that, of course, our brain works, these artificial neural networks, which again can process data and make decisions. And then lastly, really popularized, I guess, over the last couple of years, this idea of generative AI. And whether you've been directly exposed, whether it's through ChatGPT, for example, and in case you didn't know, actually, GPT standing for generative pre-trained. And this is going to be important because it's using those large language models, so you don't have to do the training yourself. But what it gives us the ability to do, of course, is through a prompt. So we go to ChatGPT, or as we're going to see, other mechanisms that may expose generative AI solutions, and then it can provide new content based on what you've prompted it to do. So again, just defining the terminology, generative artificial intelligence, or AI, of course. There's the definition of AI, as we've seen earlier on. So again, mimicking or imitating human behavior by using machine learning. But the generative AI part of it, of course, building this into some kind of application and then taking the input, natural language, and maybe generating some responses. So whether you've used this in the past for creating new novel content, or whether it's, again, language content it's generating, or pictures, or potentially even code. So those of you who are in that kind of space where you're developing software, this can make life a lot easier after that. James, absolutely. So I've just seen the question. The recording will be available after the session. Absolutely. So if you do need to get away, it will be sent through after the session. So yes, the recording will be coming through in the next few days after the content has been reviewed and recorded. So really, the generative AI, as I've mentioned already earlier on when we were talking about natural language processing, it's really powered by these large language models, LLMs. So they're specialized machine learning models that you can use to perform NLP tasks, natural language processing tasks. And that's hence why, of course, we needed to understand what NLP was. So again, what these large language models can do is save you having to do the training yourself because they're already pre-trained. So hence that generative pre-trained, or GPT, but it can then be used for whatever criteria. Am I looking for sentiment analysis, classification of that text, summarizing the text, looking for semantic similarity between the text, or even generating new natural language off the back of that. So that's really the important part of it. Perfect. Thanks, James, for the question, and hopefully that'll help you out, because as I say, if you do need to drop out, of course, know that you'll get the recorded version of the session, which you can review once that's been sent through to you, hopefully sometime later this week. So I think that's probably a good place for us to take a break, because we get into the specifics of how these large language models have been trained, and it can be quite technically heavy, which you don't really need to know the level of detail that we're going to be providing, but I will provide them because we've got them in the content in case you're interested. But the beauty of these LLMs is they are available by Microsoft and their relationship with OpenAI, so you can just use the same models that ChatGPT uses directly within your own applications and systems as need be. So those LLMs, those large language models, are available, but I think it's a good place to take a bit of the stretch break. And the final part of the session is really focusing on the generative AI discussions. So if I can return back to my slides, and of course, just remind you that, of course, generative AI really is a subset of deep learning. But the important thing is, of course, it's generating new content, new novel content. and it's pre-trained using these large language models. So Microsoft, in partnership with OpenAI or other organizations, they take an internet scale amount of data and they've used that as part of the pre-training, and hence this idea of GPT, generative pre-trained. So you don't have to do the training yourself necessarily. You can take advantage of what that pre-trained model can already do. So I think this was the slide that I was at. So these are the kinds of things that we can potentially do with it. So generating new content, summarizing content, so on and so forth. Now, there's a little bit of background, which is why I wanted to stop for the break before I will go into this level of detail. Whether you need to know this level of detail, questionable, but again, depends on your interest. Maybe if you are building your own large language model, absolutely understanding what's happening is going to be an important thing. But what happens is these LLMs, either if you're building them or using the pre-trained ones, they go through a bit of a transformer model. And there's two components to this transform model, something which is called the encoder, which creates the representations of the training vocabulary, and then combining that with the decoder, which generates the new language sequences. So that's the kind of encoder decoder, which is actually being represented here. So we can see the encoding and the decoding. So the encoder decoder here. Also, as part of the LLM, the large language model, the text gets tokenized. So it actually builds unique numbers for each word or phrase. And then it also creates embeddings where it can actually look at the values of those tokens and see them from a dimensional perspective. Again, you'll get a little bit more of a visualization because I know there's a lot of terms that are being introduced all in one slide here. And then attention examines the tokens in turn to see the relationship between those tokens. And then if we're using this, the decoder can then use those relationships to predict the probable sequence of the tokens. Like I said, this is a lot of detail, but let's see if we can just break this down a little bit over the following slides. To understand what happens during the tokenization, the encoding part of the process, is it's going to take the words that exist within a particular sentence. So this, again, could be sentence that you're feeding in if you're building your own large language model, or of course, internet scale data that's already happened as part of this tokenization. So example sentence we're working with here, I heard a dog bark loudly at a cat, which it's a regular occurrence in my household. I don't know, at least one other person said also a dog owner. But looking at that sentence through the tokenization process, it will allocate numbers to it. So just for kind of sense, to get a sense of this, the letter or the word I tokenized into the number 1, heard. Apologies, my slides have somehow got a little bit whacked out. But yeah, the word heard would be giving it the number 2, A, the number 3, so on and so forth. So that's the tokenization. And of course, it also suggests, hey, I heard a cat. Could be tokenized with the numbers, and of course, because we've already got the 1, 2, 3, and 8 as for that particular sentence. So again, this is the part of the process that will happen as part of that encoding. The next thing that the large language model will do is it'll look at the relationships between the tokens. So these are all captured as numbers. Because of course, some machines work better with numbers, so they need to have vectors or numbers that they can work with. And this is referred to as the embeddings. Apologies, it looks like my slides have got slightly out of whack. It doesn't really matter so much. But what I want to show you here is, of course, it's got all of the tokens, and it's looking at their embeddings. So dog, cat, bark, and meow are in close proximity to each other. Right? So it kind of understands the relationships between those different tokens. And then we've got something that's way out of whack there, out of the context here. We've got the word skateboard. Now, this always reminds me of the crazy time that I was out with my 2 dogs, and one of my dogs, she absolutely hates skateboards. So she was chasing after this person when she was off leash, and she was trying to bite this person's skateboards. Generally, dogs and skateboards as far apart as possible. Let's go with that. But I guess the idea of this is really just understanding what the relationships are between these words, my kind of separate story apart. What it can then do is it can pay attention. So this is actually quite an interesting idea. It was a white paper that was actually created by Google that really started to bring generative AI to where it is these days through this idea of attention. So let's not just look at purely at the vectors. let's look at the strength of the relationships between, sorry, the vectors, I said the tokens. Okay. So then certain things can give a greater weight between them. So as this suggests, it's got to predict the word that's going to come after the word dog. Okay. So if we take I heard a dog as a vector, and then look at the two words, the two tokens there for heard and dog, give them more weight, and then make a prediction as to what the next token would be. So in this case, as we can see here, as part of the process, it's going to predict the next word is going to be the word bark. Okay, so again, relatively simplistic for us to think about, but getting a computer to do this, quite challenging. So of course, this really all came about. This is really what's made generative AI where we are now, because this idea of this attention, and like I said, it all came from a white paper that Google initially released, people working at Google released. So at that point, we need to be able to take advantage of these large language models. So let's break away before I go into this Copilot's discussion. Maybe there are some pre-trained models that you want to take advantage of. So now I can probably build greater context. If I go back into my demo browser, where I was showing you before, and like I said, I'm sure a lot of you have experimented. Maybe you've got a policy that's put in place for your organization in terms of use of generative AI. But within Azure AI Studio, you can take advantage of the pre-built models that are already there, including ChatGPT. So ChatGPT, fewer newer versions of that. So GPT 3.5, version 4.0, DALL-E could be one of the other ones that we might want to use to take advantage of. So this, from the close relationship that Microsoft have with OpenAI, you can take advantage of their pre-built models, their large language models that you can take advantage of. But even organizations like Meta and their models are available for you to use in Azure in Azure AI as well. So again, we can build something based on that. At that point, of course, we can test them out. And this is where those playgrounds, which I can't demonstrate to you because, as I said, you'd have to go through the process of getting support for this in the subscription that I'm currently logged in with. I don't have access to that. But this is where we can then start and use very much a ChatGPT-like interface and submit some information through a prompt and get the responses. So we can test out, is this going to meet our criteria? Now, as we're going to see a little bit later on, maybe if there's pretty standard things that you're doing, we're going to talk about prompt engineering. That's going to come up very, very shortly. Maybe it's some standard things that you're looking to do with the generative AI. So as we can see here, built directly into Azure AI Studio, we've got this prompt catalog, which covers off some potentially common things that you might need to do. So again, you don't have to reinvent the wheel necessarily. You can take advantage of working with generative AI. And maybe what you're looking to do is turn some natural language, turn it into Python, for example. Or, you're looking at things that are pictures of what an image should look like, and then looking for defects as it's rolling off the factory floor or whatever it might be. So you can see quite a few things there that you can take advantage of, which allows you to build your prompt. And hopefully terminology-wise, you're already familiar with prompt. Prompt is what we're typing into. If you've ever looked in ChatGPT, it'll prompt you for something. And of course, you'll put something into that prompt. And again, we may want to optimize how that prompt works. And that's that prompt engineering discussion that's going to come up later on. Okay, what if we don't want to build anything ourselves, but we want to take advantage of some of this generative AI? As you may have seen, there's been a lot of talk from Microsoft around this, the idea of copilots. So copilots building generative AI capabilities directly into applications as need be. So you as a developer may want to build copilots that you can incorporate within applications, websites as need be. And I guess as this suggests, maybe business users can take advantage of those copilots, again, to aid productivity and create new content as need be as well. So copilots directly in Microsoft's browser, directly in the search engine, directly in GitHub, which can help with generating language as need be for any content that you're actually looking to do as a developer. So yeah, you're coding, that's the word I was looking for. So again, maybe you've already seen these. I might just have a quick demonstration in case you haven't. So if I'm directly in the Edge browser, let's just see if I can find something that's going to be useful. Let's go into the Edge browser and the Copilot's built directly into there. Let's go in here to Copilot, and from here we can say, well, I don't want to read this whole article on this BBC website. Can you just generate for me, a page summary? And of course, it will then look at the content using, of course, its large language model accordingly, and give us a summary of that current topic. So yes, rather than me reading through all of that potentially, I've got a summary, of course, that's been provided by that Copilot directly within Edge. But not only can it help with, of course, generating like this content, we can also compose new content directly within the Edge browser if we're needing to do this. Again, maybe you're posting something on LinkedIn, and you want to say that you've accepted a new job at Microsoft like this suggests. Of course, it can generate that text for you that you can incorporate in a blog post or whatever the criteria might be. So it's kind of giving you that chat GPT functionality directly within, in this case, the browser. So that's one example of a Copilot, and that's built directly into Edge. Again, some of you may be Windows users, some of you might be running Mac OS, etc. Of course, Microsoft have also been putting a preview version of Copilot directly into Windows. So of course you can then get directly access to this. So here's some things that I've kind of played around with before. Excuse me. So in my prompt, I asked the Copilot, okay, what kind of things can the Copilot not help it with? And of course gives me the list of things, which kind of leads us down these discussions around ethical decisions, etc., etc. And of course, random things that I've tried out as well, just for the fun of it, telling a joke. Okay. I've got a background in yoga, so I wanted to find out more about some yoga postures. So I think I have some questions around that, etc., etc., etc. So you can kind of see that you can just prompt it. Okay. Also talking about toxicity, how generative AI can be toxic with maybe manipulation, hallucination, generating what could be seen as being content, but could be fictional. So it could be leading to misinformation. So part of the challenge, I guess, that we're dealing with these days is, how do we kind of deal with misinformation that could have been generated, of course, by generative AI solutions. So of course, then the ethical impact of all of that as well. So, again, just an example, I guess, of the kinds of things that you can be prompting Copilot for, just like you can with, I guess, going into ChatGPT. But yeah, thinking about things like deepfakes and the impact that they're having, of course, being able to identify something that's a deepfake and something, of course, that is genuine content. Okay, anyway, that's Copilots as a brief overview. And of course, they also show you how you can use this to generate code in the GitHub Copilot. But if I move away from there, some of the things that you may need to plan for would be this idea of prompt engineering. So prompt engineering, really improving the way that the generative AI solution will work, essentially, by providing it some kind of examples or some grounding data. So examples of how you can provide prompt engineering. So again, with a direct request, as it suggests here, so clearly someone who's in Edinburgh in Scotland, okay, give me a list of, or planning on going there on holiday, so give me a list of 10 things I can do in Edinburgh during August. And that's a kind of direct language, the way that you can actually just prompt and say, provide this. But also you can kind of tell the prompt how it should act. So the way it's going to be responding, helpful, assistant, respond in a cheerful, friendly manner. Of course, you can define that as part of your prompt engineering. You can also give it examples if need be. So LLMs or large language models, they'll generally support what's called a zero-shot learning. So you don't have to give it examples. However, you can provide some examples and say, okay, if I give you this text, well, that's positive sentiment, and I give you this is negative sentiment, or whatever it might be. You can give it a few shots so it can help it understand, and then you can give it some text that it hasn't seen, and of course, then tell it to say, is this positive or is this negative sentiment? But yeah, here's an example of, maybe, again, getting some examples if need be. And then finally, some grounding data. Okay. When you specifically say, okay, include the email text with the prompt, summarize my email. Again, you're providing some grounding data that we provided as part of that input. So really, that's part of the things that you may need to plan for with your generative AI is that prompt engineering. And again, just as a bit of a breakaway from the slides, to reiterate the point that I was making earlier on, so that you don't have to invent the wheel. We've got some prompt catalogs that you can take advantage of. So sample prompt to see how it works as a starting point, okay? And then you may customize it, see how well it performs before integrating it into your application. So really there's the story I was mentioning before. And as I said, it means that it can simplify your process in terms of what you need to do for prompt engineering. And funnily enough, that's all part of the Azure AI Studio. And continuing, I guess, with this Azure AI discussion point, the fundamentals. Hopefully you've picked this up already. The Azure OpenAI service is Microsoft's cloud solution for hosting large language models. So we can take advantage of the pre-trained generative AI models, customize its capabilities. It's got tools to help you with detecting and mitigating harmful use cases. So again, we can meet the AI responsibility criteria that we may need to implement. Also, limiting and controlling things. It's built directly using role-based access control, where you can implement role-based access control and have it not, of course, directly accessible from the internet, so running on your private networks for your applications to use. So standard ways that you can interact with Azure OpenAI, as I've been demonstrating for the session, Azure AI Studio, but also you can make calls through REST APIs, software development kits, and the Azure command line interface. So again, however you'd like to interact with it, you can. But just remember, as I said, you'll need to apply for access to Azure OpenAI, again, to make sure that they are then able to identify whether you're going to be using it responsibly and you meet the criteria that they've specified. So which models can you take advantage of? As you hopefully have seen from my demos, okay, what I like to use the GPT-based models, so GPT 3.5, 4, and even now 4.0 is available for you to use, generating language and code as need be. Embeddings, which can convert the text into those numerical vectors that we talked about previously. So of course, it can look for text similarity, or there's also support for DALL-E, which can help to generate original images from natural language. I don't know why, but it's in my slides. Maybe you want to have a picture of an elephant with a hamburger. For the life of me, can't quite work out why. I'm sure there's a reason. But yeah, there's an example, and I think that's one of the last pictures I end up with. And I don't know whether you've tried random things in ChatGPT, building pictures of things that, yeah, pretty senseless. But yes, whether that is something you want to do, of course, you can use it and take advantage of DALL-E. So how to use it? Well, I guess you've seen a little bit that I've demonstrated. But yeah, building and deploying the AI models for your applications, backed by those generative AI models that have already been pre-trained for you, GPT, embeddings, DALL-E, and more, of course. There's ones from Meta / Facebook and et cetera, et cetera. Also playgrounds that you can use just for testing things out without having to code as well. Here's an example of how you could use the Azure OpenAI natural language capabilities. Add a prompt, of course, the user may type in, whether this is for your organization or an internal thing that you're testing out. Hey, I've got these particular ingredients. I'd like to make a fruit pie. Give me an example of how I might have a recipe to make that based on these ingredients that I've got. Sounds tasty or looks tasty. Likewise, maybe from a practical perspective, what you're looking to do is generate, of course, code. So for those of you who are code generators or you're kind of creating software, maybe what you need to do is, of course, use this to help build the code, or maybe in this case, for doing some testing of the code. In this case, you basically say, hey, I need to build out what's called a unit test, which are going to test this code, which in this case is just multiplying two numbers together. And we're going to make sure that the code is working the way it's expected to, because we should say, hey, if it's these numbers, yeah, 3 and 4 should always give us a number of 12. 0 and 10, or 4 and 0 should give us a number of 0. So again, here's our unit test. And of course, the code can be generated, so you don't have to create that unit test yourself. So as developer, you get the benefits of not having to create code. As I mentioned, of course, using Azure OpenAI's image generation capabilities. So it can work with DALL-E, which is it's a language model rather, which supports image creation, image editing, and image variations. And you can define, of course, your style and your requirements as well. So again, maybe making any of those changes. But like I said, for the life of me, maybe there's a reason. I haven't really looked into it too much. But yes, I'd like to have 4 variations of an image of an elephant with a hamburger. And in this case, the hamburger is obviously quite independent, maybe not the elephant eating the hamburger, which would probably make sense, I think, given I think most elephants are not carnivorous, if I'm not mistaken. But anyway, I'm going off on a sideshow and side tangent. Yeah, looks like a UFO disguised as a burger. Yeah, it does make you wonder, doesn't it, Nitesh? I would have to agree with that one. Now that kind of rolls us back to the earlier discussions. Now, if you are in kind of going down the path of a generative AI project, that responsible aspect certainly needs to be considered, because now we've got potential for abuse. So what are the potential harms? So as part of your project, as you're deploying out this responsible generative AI solution, identify any potential harms that could be relevant to your plan solution. And then, of course, once you've identified them, measure the harms that they may have and put some mitigations. And the good thing is Azure OpenAI has mechanisms to help you with mitigation. But as I said, this is obviously not something you want to roll out without really testing and making sure the impact is not going to be felt. And of course, the reputational damage that may come if you're rolling out a solution that's to the general public, if this hasn't been considered. I know that, again, there's been talks from other cloud providers and some of the impact that their solutions have had. So again, thinking through these stages for any organization, of course, that's going to start working with a generative AI solution. Now, these references, these resources I've gone through, these slides are actually taken directly from some Microsoft Learn content. So if you want to repeat this content, you want to use this as a bit of reinforcement, of course, there's going to be the recorded version, as I was saying, in response, I think, to James's question earlier on. But I've got a couple of references to Microsoft's Learn portal, which, if you're not already familiar with, gives you access to content that you can use to review. So again, it's part of your continued learning. If you want to have a look at the links that I've just popped into the chat window, getting started with AI on Azure, and also an introduction to generative AI. At the moment, Microsoft are also running a bit of a challenge. So if you find this is useful to start your journey, let me see if I can find where I had this. So they've got a challenge that they've currently done, which is really trying to engage people, I guess, in artificial intelligence and help people learn the process. So there's a cloud skills challenge that I'm going to just pop into the chat window. And I think it runs for about a month, and you can choose the challenge that you're interested in. There's one particularly around Azure AI, and you'll be able to claim a digital badge as part of the process. So you want to put that on your LinkedIn profile or something like that, because it'll give you something you can focus your attention on that relates to the content we've covered off. Now, over and above that, they've also got challenges on GitHub, Copilot, the Copilot for Microsoft 365, or building your own Copilots as well. So again, maybe depending on which kind of the side of the spectrum you are in. All good, Etienne, thank you so much. Like I said, the recording will be coming through. If you can complete the end of course survey, because we've only got a few slides, that's going to remind you of this as well. But yes, we've got 2 surveys. There'll be one that'll be the QR code that I shared at the beginning. But yes, if you and anyone else can, of course, just complete that, that will register, of course, your feedback to Microsoft. There's also an end of survey from Bespoke as well. But yeah, so there's a bunch of resources there that you might find useful. Continue your learning. Of course, at Bespoke, we run training courses. So if you wanted to have more of this interactive, engaged training course with some labs that we would walk through, we've got some learning paths that tell you about Azure AI fundamentals. There's a 1-day training course around that. Azure administrator, and also an Azure AI engineer. So have a look at this link here, bespoketraining.com/Microsoft Azure certification. If you want to find out more about those kind of virtual instructor-led training courses that we run. And there's also an Azure AI fundamentals training course and certification that you can go through from Microsoft. Again, links for that. We've got the 1-day course if you don't want to go through the Learn content. So you may find that useful. And it relates to a lot of the content that I've been covering off. There will be a survey that's coming from Bespoke. Again, our Azure AI fundamentals course that's coming up soon. So if you are interested in that, of course, feel free. And that's part of the Bespoke survey that will kick in after you close the Zoom session. There's the Microsoft survey. That's feedback to them. So do have a look at that link. So please do use that code or that link to get into it. But at this point, yeah, we're finished a little bit earlier, which I expected, to be honest with you, even with the demos, etc. We've gone 75, 77 minutes. So I really wanted to leave the last 10 minutes open in case you have any questions. But also to thank you, of course, for your time and patience. I know, of course, busy lives, but if you have any questions, feel free to post them in chat. Otherwise, enjoy the rest of your afternoon, or time that you've got left today, depending on which time zone you're in. Please feel free to post any questions that you have in chat window. I'll hang around for another 5 or 10 minutes if need be. But if I can ask you all to complete the survey, and thank you all for your time and patience today. Hopefully it's been useful, and good luck with your continued learning. Yeah.